Hello guys, welcome in today's session. I am Professor Fayaz Khawadi from Department of Mechanical Engineering. In the today's session, we are going to discuss the application of epicyclic gear train used in differential unit of an automobile from the unit gear train from theory of machine subject. When the vehicle is taking a turn, the outer wheel will have to travel a greater distance as compared to inner wheel. That is the requirement while taking the turn by the vehicle. So the outer wheel have to run faster than the inner wheel because at that time the outer back wheel has to cover more distance than the inner back wheel. As you can see in the photograph, the outer wheel has to travel more distance as compared to inner wheel while taking the turn. So a radius of curvature of outer wheel is always greater than the radius of curvature of inner wheel. That is the requirement while taking the turn by the vehicle. So this condition is satisfied by the unit used in automobile, and that unit is called as differential unit. The location of differential unit in the automobile is backside of the vehicle, and the power or rotation from the engine shaft to the back wheel is given through the differential unit mounted on the rear shaft of the vehicle. So bevel gear is generally is like a frustum of a cone. On the inclined surface on the frustum of a cone, the teeth are cut as you can see in this image. So when the teeth are cut on the inclined surface, the axis of rotation of two bevel gear are perpendicular to each other and intersecting at each other at one point. Why? Because both the axis of rotation of the shaft is on a single plane, so the axes are intersecting axis. So as you can see, the motion is transmitted through perpendicular to due to these bevel gears. Okay, so whenever you have to transmit the power or motion through 90-degree, at that time the bevel gears are used in the application. The bevel gears are used to make a more compact epicyclic system, and they permit a very high speed reduction with few gears. The useful application of the epicyclic gear train with bevel gears is found in differential unit of an automobile. Here you can see the differential unit in this image, in which this yellow bevel gear is connected to engine shaft. The power is getting to this bevel gear from the engine through propeller shaft and through gearbox. This power is given to this wheel, and this whole assembly of the epicyclic gear train is called the differential, which is enclosed in an automobile. And the half axle is connected to left wheel, and half rear axle is connected to right wheel, and power is given through 90-degree to that rear wheels. The differential gear used in rear drive of an automobile for transmitting the motion from the engine shaft to the rear driving wheels. And the second purpose of epicyclic gear train used in differential is to rotate the rear wheels at different speed while the vehicle is taking a turn. This is an important application which is satisfy the differential unit. This is the requirement of the vehicle while taking the turn, that the inner wheel should rotate with lesser speed as compared to outer wheel, because the outer wheel has to travel more distance. So both the wheels have different velocities while taking the turn, and this function is satisfied by the differential unit. Now see the construction of differential unit, how in the differential unit is getting different speed for both the wheels. Here you can see the bevel pinion denoted by P, which is getting power from the engine. This shaft on which the bevel gear is mounted, this is connected to engine through the propeller shaft and gear assembly. To that bevel pinion, this is bevel pinion. Here you can see the rotating bevel pinion, which is connected to the shaft, and further it is connected to engine shaft. Okay. This bevel pinion is connected to bigger bevel gear, and this bigger size bevel gear is called as crown wheel. Crown wheel. So motion is given from the engine to that bevel crown wheel through that bevel pinion. Okay, this bevel pinion, this bigger size wheel is called crown wheel. To that crown wheel, cage is mounted. Cage, and this cage is fabricated on that bevel or crown wheel. This cage is fabricated on crown wheel. It is directly welded on the crown wheel, so that cage is rotating along with crown wheel. If crown wheel rotate, this cage will also rotate, because this cage is integral part of that crown wheel. You can see here, as crown wheel is rotating, along with crown wheel, this cage is also rotating, because this cage is directly fabricated, is directly welded to that crown wheel. So when crown wheel will rotate, this cage will also rotate. Okay. Now to that cage, two planet pinion is mounted. Two planet pinion is hinge supported, is pivoted to that cage. These two is called as planet pinion, which is directly pivoted to that cage. Planet pinion. These are called planet pinion. And to that planet pinion, two sun gear are mounted. You can see in this image, sun gear B and sun gear A is meshed with that two planet pinion. The sun gear A and B having same diameter, so number of teeth on sun gear B and sun gear A is same, equal. Number of teeth TA is equal to TB, as diameter is same. Diameter is always same of sun gear B and sun gear A. And sun gear B is connected to half axle of the differential unit, and sun gear A is connected to half axle. This half axle is further connected to a right side back wheel, and this half axle which is connected to sun gear A is getting motion, and this further connected to left hand side back wheel. Left back wheel. Here you can see this is connected to left back wheel, and this shaft, this rear axle, half axle is connected to a right side wheel, back wheel. Okay. This is constructional detail of differential unit. This A is a relative motion with C, crown wheel. This A sun gear is having relative motion with the crown wheel. Here you can see here some mechanical component like bearing is mounted so that the relative motion between A and C you are getting. That means when C is rotating, A is stationary, or these have different speed. So this is constructional detail of differential unit that you have to clearly understand for understanding the working of differential unit while the vehicle is moving on a straight road on or vehicle is running on curved surface. Now come to the next point for understanding the working of differential. First condition, when the vehicle is running on a straight road. When the vehicle is traveling on a straight road, both will travel at same speed. When the vehicle is traveling on straight road, both the wheels travel at the same speed. Thus, the planet pinion do not spin. You can see in this image. We are getting power from bevel pinion to the crown wheel. That motion is given along with the crown wheel. These two sun gears are mounted. But at the same time, these two planet pinion, here you can see these are planet pinion. This planet pinion is not rotating. There is no relative motion between this planet pinion with the crown wheel. These are stationary with respect to this crown wheel, with respect to this cage. Okay, with respect to cage, these are not spinning, these are not rotating. So when the vehicle is moving along a straight path, the planet pinion is not rotating. Instead, as the transmission shaft turns the crown wheel, the rotary motion is translated directly to the half shaft or half axle, and both wheels spin with the angular velocity of the crown wheel. See here, the motion is from the planet pinion is given to the crown wheel. This along with the crown wheel, the cage is also rotating, but there is no relative motion. And when the cage is rotating, these two planet pinion is not rotating, is not spinning about that pivot point, pivot axis. So this motion is directly given to that two sun gear. Sun gear A, this is sun gear A and this is sun gear B. So sun gear A and sun gear B is having same angular velocity. Same angular velocity. Here you can see omega 1 is equal to omega 2. Angular velocity of half axle, left-handed half axle is equal to angular velocity of right-handed half axle. So while taking the turn, both the wheel is having same angular velocity. So omega 1 is equal to omega 2. Why? Because with respect to that crown wheel, this two planet pinion is not spinning, is not rotating about its own axis. That's why the same motion is given to that sun gear A and B. Now consider second condition, the vehicle is taking a turn. When the vehicle is taking turn, the wheel must move at different speed. If suppose the vehicle is taking left turn, the inner wheel, the left-handed wheel should have lesser speed as compared to right-handed speed. So in this situation, the planet pinion spin with respect to crown wheel. See here, the planet pinion, these two are planet pinion. These two are planet pinion. So while taking the turn, this planet pinion is also spinning about that pivot point. That is the difference. And why this is spinning? Because this planet pinion is stationary and crown wheel is rotating. So along with this crown wheel, this is stationary, so this stationary, this is rotating. So along with this cage, these two planet pinion are spinning, and this motion is given to only that left-handed sun gear, left-handed sun gear. So this right hand wheel is getting motion from that crown wheel, and this is stationary. So and left-handed rear wheel is getting motion from that sun gear, sun gear. So diameter of this crown wheel and diameter of this sun wheel is different. So speed will be different. So left hand back wheel is different speed and right hand back wheel is different speed. This happen only that planet pinion is spinning, and in case of straight moving, this planet pinion is not about spinning, planet pinion. So if this is not spinning, this two gear sun gear is having same angular velocity. But in case of turning, this sun gear is stationary, this sun gear is stationary, and this planet pinion are spinning. So this motion is given to that wheel. Okay, so that things you have to clearly understand. So the speed of left hand wheel omega 1 is greater than omega 1 is less than omega 2. So due to this, both the wheel having different angular velocity. This allows the speed of crown wheel to be delivered unevenly to the two wheels. So due to this epicyclic effect, the speed of inner rear wheel decreases by the certain amount, and the speed of outer wheel increases by the same amount. That is the speciality of differential gear unit. So I again explain here, while taking the turn, these both planet pinion having shown here by blue color, these are not spinning. So you are getting omega 1 is equal to omega 2. But while taking the turn, these both blue color planet pinion is spinning. So this green color planet sun gear is matched with these both planet pinion. So that motion is transferred to that green bevel gear, which is known as again sun wheel, and this is having different speed, and this wheel right side axle is getting motion from that crown wheel, so that wheel is having different motion. So you are getting omega 1 is not equal to omega 2 while taking the turn. This is the specialty of differential unit used in automobile. So at the end of this session, the student can understood the bevel gear and the differential unit, and how the differential unit works while this vehicle is moving on a straight path, and while the vehicle is moving taking a turn on a curved road. So thank you so much for attending this session.